What do the sentence 2 plus 2 equals 4 and the sentence God is good have in common? It might seem like nothing, but in mathematics and logic, they are both perfect examples of the same thing, a statement. And understanding what makes a sentence a statement is the first and most important step into the world of logical reasoning. For the past few lessons, we've been organizing objects and collections using set theory. Now we're shifting gears to learn how to build arguments and prove that things are true. The fundamental atom, the basic building block of a logical argument, is the statement, which is also called a proposition. But it has a very precise meaning in mathematics. So, what is a mathematical statement? A statement is a declarative sentence that is definitively either true or false. That's it. But both parts of that definition are crucial. First, it must be a declarative sentence. It has to claim something. It can't be a question, a command, or an opinion. Second, it must have a clear truth value. It can't be ambiguous, and its truth can't depend on unknown information. If we can't label it as either true or false, it's not a statement. Let me break this down into two key requirements. Requirement number 1, the sentence must be declarative. In other words, it claims something. Requirement number 2, it must have a clear truth value. It must be definitively true or false. If either of these requirements isn't met, we don't have a valid statement. To make this crystal clear, let's imagine we have a statement sorting machine. We feed sentences into this machine, and it determines whether they are valid statements or not. The machine has 3 possible outputs: true, false, or error. Let's test some examples. Example 1. We feed in 2 plus 2 equals 4. Let's check. Is it a declarative sentence? Yes. Does it have a clear truth value? Absolutely. This statement is true. This is a valid statement. Example 2. We feed in the earth is flat. Is it declarative? Yes. Does it have a truth value? Yes, it does. Even though this statement is false, this is also a perfectly valid statement. You should know that a statement doesn't have to be true. It just has to have a truth value. Example 3. We feed in, where did you go? Is it declarative? No. This is a question, not a declaration. This is not a statement. Example 4. We feed in, please pass the salt. Is it declarative? No. This is a command. It's not true or false. Error. This is also not a statement. Example 5. We feed in x plus 5 equals 10. Is it declarative? Yes. Does it have a clear truth value? No. Its truth depends on the value of x. If x equals 5, the statement is true. If x equals 6, the statement is false. Since we don't know x, it has no definite truth value. This is called an open sentence. Error. This is not a statement. Example 6. We feed in, this sentence is false. Is it declarative? Yes. Does it have a truth value? Let's see. If it's true, then it must be false. If it's false, then it must be true. It can't be assigned a truth value. This is a paradox. Error. This is not a statement. Every if statement in every programming language is an evaluation of a logical statement. Consider this piece of code. If user age is greater than or equal to 18, grant access. When the program runs, user age has a specific value. Let's say 25. The computer evaluates the condition by substituting the value, creating the statement, 25 is greater than or equal to 18. This statement is true. Because the condition evaluates to a clear boolean true, the computer knows to execute the code inside the block. If the age were 16, the statement would be false, and the computer would skip the block. Without this strict binary of true or false, computers couldn't make decisions, and none of our software would work. Let's recap. A statement, or proposition, is a declarative sentence that has a definite truth value of either true or false. It cannot be a question or a command. It cannot be an open sentence with undefined variables. And it cannot be a paradox. Now that we know how to identify a valid logical statement, we can start to combine them to build more complex ideas. In our next lesson, we'll learn about the 3 fundamental logical connectors that allow us to do this: and, or, and not. See you there.